Hello everyone, I am Sandeep Shukla, Assistant Professor in Electronics and Communication Engineering in TID College, Bhopal. In today's session, we will discuss about the CRO, that is the topic of electronics and measurement instrumentation. This is the real picture of CRO, cathode ray oscilloscope, and this is the schematic block diagram of CRO. So you can see the block diagram of both, and about CRO, you can see in details in this slide. So the cathode ray oscilloscope is a multi-purpose display instrument used for the observation, measurement, and the analysis of waveform by plotting amplitude along y-axis and time along x-axis. CRO is generally an XY plotter on a single screen. It can display different signals applied to the different channels. It can measure the amplitude, frequencies, and phase shift of various signals. Many physical quantities like temperature, pressure, and strain can be converted into electrical signals by the use of transducer, and the signals can be displayed on the CRO. A moving luminous spot over the screen displays the signal. The CROs are used to study the waveform and other time varying phenomena from very low to very high frequencies. You can see the block diagram of CRO in this slide. The CRO is electronic equipment which displays a time varying signals or waveform, and the electron beam which is produced by the electron guns get deflected in both vertical and horizontal plane by a pair of vertical deflection plates and a pair of horizontal deflection plates respectively. Finally, the deflected beam will appear as a spot on the fluorescent screen. You can see here, this is the electron gun, and this one is the vertical deflection plate, second one is the horizontal deflection plate. And when electron beam is produced by using electron gun, then both plates, vertical and the horizontal deflection plate, both controls the electron beam and focus on the screen of the CRO. CRO consists of a set of various parts. First one is the vertical amplifier. You can see the vertical amplifier in this picture, this first block diagram, that is the vertical amplifier where input signal is applied. Vertical amplifier amplifies the input signal which is to be displayed on the screen of CRT. Second one is the delay line. Delay line provides some amount of delay to the signal which is obtained at the output of vertical amplifier, and this delayed signal is then applied to the vertical deflection plate of CRT. Third one is the trigger circuit. Trigger circuit produces a triggering signals in order to synchronize both horizontal and vertical deflection of electron beams. Time-based generator, you can see here the time-based generator. Time-based generator produces a sawtooth wave which is useful for horizontal and deflection of electron beam. Next one is the horizontal amplifier. Horizontal amplifier amplifies the sawtooth signal and then connects it to the horizontal deflection plates of CRT. You can see here horizontal plate connected to the horizontal amplifier connected to the horizontal deflection plates. Next one is the power supply. It produces the both high and low voltage. The negative high voltage and positive low voltage are applied to the CRT and other circuit respectively. And the next part of this CRO is the CRT, cathode ray tube. CRT is a vacuum tube that acts as the main part of the CRO, and you can see the main function of CRO. The cathode ray is a beam of electrons which are emitted by the heated cathode and accelerated toward the fluorescent screen. The assembly of the cathode intensity grid, focus grid, and accelerating node is called an electron gun. Its purpose is to generate the electron beam and controls its intensity and focus. Between the electron gun and fluorescent screen, the pair of metal plates, one oriented to provide the horizontal deflection of the beam and one pair of oriented to give the vertical deflection to the beam. You can see the two plates are here. These plates are referred as the horizontal and vertical deflection plates. The combination of these two deflection allows the beam to reach any portion of the fluorescent screen where the electron beam hits the screen and the phosphor is excited and light is emitted from that point. This conversion of electron beam into the light allowed us to write with points or lines of light on the otherwise darkened screen. The linear deflection or sweep of the beam horizontally is accomplished by use of generator that is incorporated in the oscilloscope circuitry. In the most common use of oscilloscope, the signal to be studied is first amplified and then applied to the vertical deflection plate to deflect the beam vertically. And at the same time, a voltage that increases linearly with the time is applied to the horizontal plates. So the causing the beam to be deflected horizontally at a uniform rate. The signal applied to the vertical plate is thus displayed on the screen as a function of time, and the horizontal axis serves as a uniform time scale. So this is the CRT. CRT is the main part of the CRO. It is the major important part of CRO and mainly consists of several parts like electron gun, vertical deflection plates, horizontal deflection plates, and fluorescent screen. You can see in this figure, this is complete figure of CRT, cathode ray tube. So first part, that is the heater. What is the function of heater? This part is responsible for heating the cathode. And the second, next part of CRT, that is the cathode. Here is the cathode. Cathode is, when cathode is heated, electrons are emitted from the cathode. And in order to achieve this, a layer of barium oxide is coated on the cathode. Next one is the grid. Next part is the grid. Grid is kept at negative potential and it helps control the intensity of electron beam moving towards the anode. And the entire structure is made from nickel. Next one is the pre-accelerating anode. This anode provides the acceleration to the anode before the entering in the focusing anode. And focusing anode, it helps align the incoming electron beam. And the next one is the accelerating node, that is accelerate the newly aligned electron beam, and both pre-accelerating and accelerating nodes are connected to a common position. Next one is the deflection plates. When the electron beams departs from the electron gun, it drifts through the two pairs of deflection plate. You can see here two plates of deflection plate, that is the vertical deflection plate and horizontal deflection plate. So one pair of plate is mounted in the horizontal direction and produces an electric field in the vertical plane. So it generates the vertical deflection and it is defined as the vertical deflection plate or Y plates. And the other pair of deflection plate is mounted in the vertical direction and it develops electric field in the horizontal plane. So this deflection plate is known as horizontal deflection plate or X plate. These plates are flared so that the beam can pass through it without striking. Next part of CRT, that is the screen for CRT. The front portion of CRT is the faceplate and the inner surface of the faceplate is coated with the phosphor. The electrical energy gets transferred into light energy by the action of phosphor. When electron beam strikes the phosphor crystal, it raises their energy level. This is known as cathode luminescence. During phosphor excitation, light is excited and this is the called fluorescence. Next part of this CRT, that is the aqueduct. The electron that strike the screen releases secondary emission electrons. Aqueous graphite solution known as aqueduct collects these secondary electrons and these aqueduct is joined to the secondary node to maintain the CRT in electrical equilibrium, and it is necessary to collect the secondary electrons. The horizontal diffraction plate system of the cathode ray oscilloscope consists of following stages. First stage is the sweep generator, or we can say the time based generator. Second one is the horizontal amplifier, and third one is the trigger circuit. And the vertical deflection plate system consists of following elements: probe, selector for input signal, attenuator toward is the gain of amplifier, and the vertical amplifier that amplifies the signals. So you can see these various parts related to the horizontal and vertical deflection plate you can see in this figure. Now come to in this slide. In this slide we will study about the application of CRO. By using CRO, we can measurement amplitude, measurement the time period and the frequency. So let us see how can measurement of amplitude, time period or frequency by using the CRO. So first we can measure the amplitude of any signal. So in the CRO displays the voltage signal as a function of time on its screen. The amplitude of that voltage signal is constant, but we can vary the number of divisions that cover the voltage signal in direction by varying volt per division knob on the CRO. Therefore, we will get the amplitude of the signal which is present on the screen of CRO by using following formula: A equal to J into NV, where A is the amplitude and J is the value of volt per division, and NV is the number of division that cover the signal in vertical direction. How can measure the time period by using CRO? You can see here. CRO displays the voltage signal as a function of time on its screen. The time period of that periodic voltage signal is constant, but we can vary the number of divisions that cover one complete cycle of voltage signal in horizontal direction by varying time per division knob on the CRO panel. Therefore, we will get the time period of the signal which is present on the screen of CRO by using following formula: T equal to K into NH, where T is the time period, K is the value of time per division, and N is the number of division that cover one complete cycle of the periodic signal in horizontal direction. And how you can measure the frequency by using CRO? You can see here. The frequency of a periodic signal is the reciprocal of time period. So if you can get the time period, then you can find the frequency by using this formula: F equal to 1 by T. So to measure the frequency, you can follow two steps. First step one is to find the time period of periodic signal, and second is the get the reciprocal of time period, that will be the frequency of that signal. Now in this slide we will discuss about the some controls of CRO. So these are the some parts of controls of CRO, that is the include position, brightness, focus, astigmatism, blanking and calibration. So we will discuss first about the position. In the oscilloscope, the position control knob is mainly used for the position control of the intense spot from the left side to right side. By regulating the knob, one can simply control the spot from left side to the right side. Brightness, the rays brightness mainly depends on the intensity of the electrons. The control grid are accountable for the electrons intensity within the electrons ray. So the grid voltage can be controlled by adjusting the electron ray brightness. Next part of controlling the CRO, that is the focus. The focus control can be achieved by regulating the applied voltage toward the center node of the CRO. The middle and other nodes in the region of it can form the electrostatic lens. Therefore, the main length of the lens can be changed by controlling the voltage across the center node. Next part of controlling, that is the astigmatism. In CRO, this is an extra focusing control and it is analogous toward astigmatism within optical lenses. A ray is focused in the middle of the monitor would be defocused on the screen edges as the electron path lengths are dissimilar for the center of the edges. Next controlling part, that is the blanking circuits. The time-based generator present in the oscilloscope generated the blanking voltage, and the next controlling part, that is the calibration circuit. An oscillator is necessary for the purpose of calibration within oscilloscope. The oscillator which is used to generate a square waveform for the preset voltage. So finally, we will discuss what is the application of CROs. So the CROs are used in huge applications like radio stations for observing the transmitting and receiving properties of the signal. The CRO is used to measure the voltage, current, frequency, inductance, admittance, resistance, and power factor, etc. These devices also used to check the AM and FM circuits characteristic. CRO is used to monitor the signal properties as well as characteristic and also controls the analog signals. The CRO is used through the resonance circuit to view the shape of the signal, bandwidth, etc. The shape of voltage and current waveform can be observed by CRO, which helps to take the necessary decision in a radio stations or communication stations. It is used in laboratories for the purpose of research. One researchers design a new circuits, then they use CRO to verify the waveform of voltage and current of every elements of the circuit. CRO is used for the comparing phase and frequencies. It is also used in TV, radar, and analysis of engine pressure. CRO is also used to check the reactions of nervous and heartbeat. In the hysteresis group, it is also used for the VH curve. Transistors curves can be tested. Now come to this slide. In this slide, we will discuss some type of oscilloscope. So this is the special purpose oscilloscope. First one is the dual beam oscilloscope. Second is the dual trace oscilloscope. And third one is the digital storage oscilloscope. So we will discuss about the dual beam oscilloscope. In this oscilloscope, you can see the figure of a dual beam oscilloscope. In this oscilloscope, which displays two voltage waveform, that is called the dual beam. Its a block diagram is shown in this figure. The dual beam CRO uses two completely separate electron beams, two sets of vertical deflection plates, and a single set of horizontal deflection plates. Only one beam can be synchronized at one time. Since the sweep is the same for both signals, that is the common time base is used for the both beam. So you can see the figure of this dual beam oscilloscope. The combination of the following blocks together, that is called a channel, preamplifier and attenuator, delay line, vertical amplifier, a set of vertical deflection plates. There are two channels in a dual beam oscilloscope. So we can apply the two signals, namely A and B, as input of channel B, and respectively. We can choose any one of these four signals as a trigger input to the trigger circuit by using switch. Those are the input signals, A and B, external signals, and line input. These oscilloscope will produce two vertically deflected beams. Since there are two pairs of vertical deflection plates in this oscilloscope, the blocks which are useful for deflecting beam in the horizontal deflection is common for both the input signals. Finally, this oscilloscope will produce the two input signals simultaneously on the screen of CRT. Now come to the next type of oscilloscope, that is the dual trace oscilloscope. The dual trace oscilloscope is nothing but a single beam oscilloscope with the input switched alternately to give the impression of two patterns on the screen. The CRO has a single electron gun whose electron beam is split into two by electronic switch. There is a control for the focus and another for the intensity. Two signals are displayed simultaneously. The CRT of dual trace oscilloscope consists of a set of vertical deflection plates and another set of horizontal deflection plates, and the channel consists of four blocks, that is preamplifier, attenuator, delay line, vertical amplifier, and vertical deflection plate. So you can see the figure of this dual trace oscilloscope. In this block diagram, the first two blocks are separately present in both channels. The last two blocks are common to both channels. With the help of electronic switch, we can connect the delay line output of a specific channel to the vertical amplifier, and we can choose any one of these four signals as a trigger input to the trigger circuit. Those are the input signals A and B, external signals, and the line input. These oscilloscope uses same electron beam for deflecting the input signals A and B in the vertical direction by using an electronic switch, and the produces two traces by the block that deflect the beam horizontally is common for both input signals. So next part, special oscilloscope, that is the digital storage oscilloscope. You can see the figure of DSO. This oscilloscope which stored the waveform digitally, that is known as DSO, digital storage oscilloscope. Additional block required for the digital data storage are added to the basic oscilloscope to make it convert into a digital storage oscilloscope. The blocks that are required for storing the digital data are lies between the preamplifier and attenuator and vertical amplifier in DSO. Those are the samples and hold circuits and A to D converter, memory, and D to A converter. The control logic controls the first three blocks by the sending various controls. These blocks like controls, logic, and digital to analog converter are present between the trigger circuit and horizontal amplifier in DSO. The DSO stores the data in the digital before it displays the waveform on the screen, whereas the basic oscilloscope does not have this feature. Last one is the sampling oscilloscope. This oscilloscope is a modified oscilloscope, and it meant for the avoiding the difficulties of bandwidth requirement, the problem of reduction in the intensity of the image on the screen of the CRO, while the working with the high frequency signals is also converted into sampling oscilloscope. It improves the high frequency performance of the oscilloscope. These are used for the frequencies above 300 megahertz. Sampling techniques are to be used to obtain a good display of the signal. The display is made up of dots of many as 1000 in numbers. Vertical deflections for each dot is obtained from the later points. The horizontal deflections of the beam is obtained by the supplying the staircase wave to horizontal deflection place. And in the sampling oscilloscope, as the name itself indicates, the input signal is not directly applied to the vertical amplifier. The waveform is reconstructed taking several samples from the recurrent cycles of the input signal. Therefore, the beam will not have the writing speed of the input signal, and then instead it will be moving step by point by point, utilizing the number of samples that may be around 1000 or more. So this is not only relax the bandwidth requirement of the vertical amplifier, but also improve the intensity of the image information. You can see the figure of this sampling oscilloscope. So, okay, students, today's session is over. Thank you.